I think it's about time we did something with this Amiga 2000 board. No doubt you've seen this a couple of times on the channel over the last few months, but I picked this up at the tail end of last year, got it from eBay, spares or repairs. Now the original listing is gone, but if I remember correctly, this board did work, although it had some corrosion in and around the old CPU socket. The owner swapped the socket and then it didn't work. But I got this on a best offer. I think it cost me about £90, which I didn't think was too bad considering it had a full chipset. Now, since then I've robbed the CPU that was there and borrowed a CIA from it, but we can soon populate that again. And let's see if we can actually get this working. So it's a Rev 4.4. It's got the 8372A 1 meg Agnes. I think this is 1 meg of onboard chip RAM. Those are 256 1-byte chips. So 1, 2, 3, 4, 5, 6, 7, 8, 256, 512, 1024. And as I said, it had the full chipset. Now, we'll do a quick test, but we obviously need to populate that missing CIA and a CPU. We'll just borrow them off the Rev 3. And I've just noticed something. The notch on that socket, to indicate what orientation the chip goes in, it's at the top. But if you look closely at the silk screen underneath it, the notch should be at the bottom. Could it be that simple? Has someone just installed that socket the wrong way around and then been trying to test it with the chip in backwards, and that's why it doesn't work? I suppose there's one way to find out. So ATX PSU on. Oh, the switch is already on. Let's see if it shows any signs of life. Not really. Almost like it's trying to boot there. Obviously there's no floppy drive attached, so it'll take a while. And now we've even lost the video signal. I do think it is resetting there, and we're getting that noise. Try a quick power cycle. We've got a purpley sort of screen. Yeah, it's just not happy, is it? Now, before we start taking things apart, I want to pull the CPU out of here. And I want to try our little adapter in the CPU slot. Now I can see a little bit of green in there. It's not too bad, it's just a little bit on the side of some of those pins. So we'll try and go in with a bit of contact cleaner. I'll give it a quick go with the toothbrush. And we'll put this CPU in here and try it again. Yeah, it doesn't seem to be doing anything at all this time. No noise, no colors. Let's try a reset. Yeah, it's just not doing anything. Now, the fact that we're getting a PAL video signal and the fact that we got color on the screen, or that noise when we had the CPU in this socket, sort of makes me think that the clocks are okay, resets okay, and obviously power seems to be okay. Let's take a quick look at what's been done to this board before. And certainly looking over the bottom side here, the only evidence of rework really is at the CPU socket, and then a couple of pins here, and that IC, what's that one? That's the ROM. A little bit of rework has happened there as well. Other than that though, it all pretty much looks factory. Although something there looks a little bit burnt. So what's that at that position? Aye, that's a diode. That diode has been replaced. D400. It's a little bit burnt on this side as well. It looks quite old though. So it looks as if that was maybe replaced quite some time ago. And that solder joint at the top side, just there, that looks as if that's a cracked joint. Now, I can't move it, but it doesn't look great. Let's just give you a close-up of the other rework. There's the bottom side of the CPU. It's a little bit rough, but I mean it does look okay, to be honest. And then there's the couple of pins that have been reflown around that ROM. So I think what we should do is undo what's been done here. We'll take the CPU socket off. I'll just reflow those points at the ROM and at that diode. Some of the traces around here do look a little bit crusty now. Obviously there was a battery here once upon a time. There must have been a bit of damage here and it's all been coated, you know, with solder mask. I can see one little bare bit of copper just up in there. So perhaps there might be some damage on the top side. In fact, there's some more of it there as well. So there might be some damage on the top side underneath that socket. Yeah, let's start by getting that off. We will use the Moo gun to desolder this, but I'm just going to try and preheat the board first of all. Just with a bit of hot air, because there are some rather beefy ground planes around here. Alright, let's see how this goes. Some of the points on this side here look like they're almost delaminated a little bit, so we'll have to try and be careful here. Couple of pads missing there, one missing there, and one missing on that pin. Don't think I did that. I think they're missing from the last repair attempt. Right, let's see if we can get that socket out. Still stuck in a few places there, perhaps. No, here it comes. It's absolutely red hot. And yeah, there's a lot more damage on this side of the board. That is definitely the problem. It does almost look as if we lifted the top of a via off there, but I don't think so. That's 1, 2, 3, 4, 5, 6, 7, 8 down on this side. 1, 2, 3, 4, 5, 6, 7, 8. That one actually looks okay on this top side. That just must have been a blob of solder that was stuck in there. So I think what we'll do, given that some of the solder points around these resistor packs are a bit crusty as well, I think what we'll do is just pull those 4 resistor packs. We'll pull those couple of caps and that single resistor there, just to give us a better look at this whole area. Yeah, I don't think any of that is off yet. Still all looks to be making a pretty good joint on this side. Might be able to get that resistor out, that single one. We will just replace these components, or well, certainly the single components anyway. Although I do want to try and save the resistor packs because I don't have any of those. So I'm going to try and get some clean solder mixed in on the top side. Let's go across it here with a bit of flux. And let's see if we can get the iron in here just to try and tidy up solder joints on this side. Or even just try to get them flowing a wee bit. So we can get the corrosion out of them, then we can hopefully try to desolder them better. Right, let's try that again with the Moo gun. It's all very nasty looking underneath there. I can still see plenty of solder on this one, so we'll just try and get it maybe with a bit of braid. Yeah, that's not going to come yet. This is always a problem when you're trying to deal with corrosion. Getting through-hole stuff out is always hard. Let's try a bit of hot air up here. Yeah, there it goes. I've lost a leg on it, so looks like I'm replacing these. I can now get at this one then, see if we can do any better with this one. I was trying to take this 4-pin header here, CN606, I was trying to take that out, but I can't really get it. The corrosion doesn't look too bad around it, so I think we could maybe just leave it. The rest of this though is an absolute mess. So I think we'll give it a second to cool down here, and we'll just try and go over it with some cotton buds and white vinegar, bit of IPA, and let's see what we're facing. So to start with, we'll just lay a cloth on the area, and then we'll soak that with vinegar. That's taking a good bit of it off, but then we'll just dump some IPA on top. Give it a good scrub with a toothbrush, and then I'll finish it off with some cotton buds. Just looking at this, actually the corrosion on the board has extended down this way quite a bit, so we'll probably have to wind up reflowing a lot of these passives. That 244, the legs of it are a bit crusty looking. There's a 245 over here that equally looks a bit crusty. Some more passives down here as well, just beside the clock chip. They're not looking the best either. But we'll concentrate on the damage that's in and around this CPU socket first. So we will need to go over this with some magnification, but I can see straight away here that we've got a fair bit of damage. There's a lifted trace here with the pad beside it. Looks like it's gone. I assume there would have been a trace going to that resistor pack. Equally, the pad there is gone. Then we can see a trace that would have continued on. Just below that, we're missing the pad as well. Looks like there's a trace there that would have went between those. That looks damaged. Bit questionable around these pads and the traces going to them. Same up here. Looks a bit dodgy. All looks a bit dodgy there. I think we've got a broken trace that would have run through those two pads. I think there's a crack in the trace here from that point. So I think what we'd be better doing is just going right around the CPU with a multimeter just to check continuity. But it just continues down this side as well. There's a damage to a trace just there. Looks like a trace should continue, underneath the CPU there, but feels as if it's actually broken at that point. And then down here things are very questionable as well. Now usually when we're doing this sort of work, to help me along we would refer to Amiga PCB Explorer, but if you take a look on that site, well, they don't have a layout for an A2000. So instead what we're going to do is use this page. This is just the component locator for the Amiga 2000 by Chucky. But I've taken a screenshot of that, and then within Paint we'll just buzz out each of these, and then I'll mark it green for good or red for bad, or considering the background's green, let's go blue for good or red for bad. I have nice new probes for my meter. It's in continuity, hopefully you can hear that okay. And pin 1 should be connected to the second pin up on this resistor pack, which it's not. Not off to a good start, are we? And it should also be connected to the CPU slot to this pin. So it's okay going that way, but it's not making any connection that way. Now I can get through to the copper of the trace, and I can read it to just beside that pad, but it's not actually on that pad itself. So there must be a break just in there. So in Paint then, I will mark that way as good and that way as bad. Right, pin 2. It should go to the 4th pin up on this resistor pack, which it does. And it should make its way across to the coprocessor slot on this 3rd pin up. And yeah, that one's fine. So as you can maybe gather, this is going to take me a while. Pin 3 doesn't go to the resistor pack, it just goes to the 4th pin up on the CPU slot. And yeah, that one's fine. But I'm not going to make you sit and suffer all the way through this. Rather, I'll just go around and we'll test all of it, and then I'll report back. Pin 4 is okay as well. Okay, that did take forever, so it's a new day. I've been right around this CPU socket and have found quite a bit of damage. But you might be able to see that I've also gone over this board. We've reflowed all of those solder points that looked a bit dodgy, and I've replaced those 3 capacitors. We will do a full recap of this board at some point in the future, but pull those out just because they were all crusty underneath anyway, so just new ones in there for now. I'm pretty happy with how the rest of it has came up, so we just need to fix these broken bits. Now if we take a look at our image, well, we've got a total of 9 broken traces to repair. The damage there at pin 1, as you've seen earlier. These 2 are going to be quite hard to repair, I think. There's damage on traces here that pass between the holes for the socket. We can repair it okay. The difficult bit is going to be making sure that it doesn't bridge when we fit the socket again. We have another one of those to repair up the top of the chip here. At that point actually, where I thought the trace looked as if it was damaged. At this point here, where I thought it looked damaged, it's actually okay. I just exposed the copper there just to confirm it. But with another trace to repair to a hole down here, and then there's 4 more of them to repair to holes towards the end of the chip. Now, while trying to tidy up the various other solder points, we did lose a pod at a position here, which has been repaired again, just with a little bit of wire through the board. And that's exactly how we're going to fix all of this. Let's take a bit of our solid wire, and to be honest with you, for the likes of this one, where it's just looping between those 2 points side by side, all we're going to do is stick that down through the board. I'll just bend it over on the bottom side to hold it, and then we'll stick it down through the hole as well at the resistor pack. And then just to be sure that it doesn't move about and short to anything else, there is a little bit of copper exposed there on the trace. Let's see if we can actually just expose a little bit more of it. We'll do that with a knife. And we'll push that wire into place, a little bit of flux on it. And we'll just flow the tiniest bit of solder just onto the middle of it there, just to hold it to the trace. Obviously don't want to plug the holes at the minute. We just need to fit the resistor pack on the socket. But that'll hold it in there nicely, and that's that one fixed. Right, these 2 are going to be hard, because the next 2 up the chip, it's where we need to repair a trace that's running between those holes. So the trace we're looking at comes through here, and it's broken just at that point. Comes through there, misses all of this actually, and continues this way, heads up towards the ROM. So I think what we'll do here is that we'll expose copper on this trace back here underneath the CPU. Then I'm just going to cut the trace, or what's left of it, heading towards these holes on the CPU. And then we'll take it back to about this point, I think, and we'll do the same again. Then this time what I want to try and do is take a bit of the wire but leave the sheath on it, and that should protect it and stop it from shorting out to the pins of the socket when we refit that. Or that's the plan anyway. So a little bit of flux onto that copper that we've exposed. Let's just tin it up. There's a block of hole there, but that's alright. I'll unblock it again. It's easy done. Got our wire made off to 1 bit of the trace. And I want to try and route this on the board in a similar fashion to what the trace was. Something like that. We'll cut off the excess. We can use a little bit of heat from the iron to pare back the sheath on it. And just make it off to the trace. That should be it. Let's check it with the meter. So it's from that pin there. Let's just go to the other side of our wire. Yeah, that's okay. Ultimately that does come over here, but you can see a bit of exposed copper there. Makes continuity to that, but it doesn't to that pad. That's where it ends up. We've got a break there to fix as well. But we'll get to that. I just want to continue working around this chip as it comes. So the next one that we need to fix is a similar sort of thing. We'll do it just in the same way. It's probably not necessary to cut the trace just like I am doing there, but I just like to do that. Just an attempt to stop any reflections or anything like that on the signals. You know, if you've got a trace running down the board that's broken, and then we connect a wire, you know, back here on it, say, well, your signal is going to come down. It's going to come down the trace into the wire, but it's also going to continue down that trace, hit this, and bounce back again. So, by my thinking, if we cut it, we're just making it off like that, and then it's just continuous. I don't know. Maybe I'm overthinking it. I just like to cut the traces when we're doing that. Okay, I'm just bend this into shape again. Now we can just use the heated iron again, just to pare back that sheath after we've cut it. And then let's get it made off. So that's those three done. I'll just crack on, get the rest of it done. And then we're going to go over it all with a bit of solder mask. Then we can fit the socket, the rest of the parts, and hopefully it works. Well, that's all of it fixed, although we did need to do a couple of extra repairs. Remember the trace there that looked damaged but buzzed out okay? Well, I had exposed the copper on it, but as soon as I tried to flow a bit of solder over it, it just lifted away. So it must have been cracked, or it was certainly damaged anyway, but it's now patched, and there was a similar trace down here, equally patched. Now before we go and refit the sockets and the resistor packs, I'm going to go over all the repair work here just with a bit of solder mask. And I typically just try to put this on just with my tweezers. I know you're supposed to use a brush or something, but this is just how I do it. Just dip the tweezers in and then go over the exposed metal work here and any exposed copper. This will also just help hold any of that repair work in place when we're, you know, fitting the component. Soldering the legs, obviously that heat's going to travel up these wires that we've fitted. I'll just stop them detaching from the board as well. Or that's the theory anyway. Right, I think that's pretty much all of it. Maybe just a wee bit there, is there? This trace looks really dodgy. I mean, there's a trace that comes along there, goes between all of that, continues that way to the V at that point, but it buzzes out okay. So I'm just going to leave it. The damage to this, where it is damaged, is it's quite bad, to be honest. But I think that's all of that covered now. And to make that go off, we'll use this UV light. I need to say a big thank you to Gadget UK. He sent me this along with a box of other goodies. He actually sent me it before Christmas, and I'm a little ashamed to say I haven't even had the chance to show you lot what's in that. There is one very cool card in it that we need to take a look at, and I promise you we're going to get to that in the next couple of weeks. No spoilers though, but he included this UV light as a part of that. And it's just perfect for dealing with this solder mask. Right, let's just reassemble and test it. We've got a 47 microfarad cap to stick in there in position C404. We've got a 470 ohm resistor to put in there in position R111. I just looked up the value of that from the schematics that are online. Now granted, the schematics are for a Rev 6 board. This is a 4.4. And one thing that I noticed interesting actually is the resistor packs, which we're going to fit in a minute. Those are actually different values on the later machine. And in fact, only 2 of them are fitted. So on this revision board, we took off 2 10K resistor networks and 2 4.7K resistor networks. The 10Ks were at positions RP901 and RP900. The 4.7Ks were at positions RP101 and RP100. On this board, those 2 are pull-ups on the data bus going to the Zorro slots. On the later boards though, instead of having pull-ups, that data bus over here has 3.3K pull downs. In fact, same thing that I have fitted to my Diego boards. But I'm not actually sure if those pull downs are on this version of the board. In fact, I suppose we could maybe try and measure it, could we? If we go on to one of those positions where the resistor pack was, and if we measure that to ground, well, there's nothing. Assuming of course that is a ground there. Yeah, it is. But there's nothing there. So yeah, Commodore in the later revision obviously thought that 3.3K pull downs would be better than 10K pull ups for whatever reason. These resistor packs over here, that's all just bus termination on the Zorro slots. These 2 here, not sure what they're connected to, but those are 10Ks. Are they pull ups or pull downs? Yeah, 10K pull down, I think. No, hold on a minute. That might have been a 10K pull up. Aye, that's reading about 150 ohms. That's a 10K pull up. And in fact, those are probably sitting on the bus control lines in here, or the bus mastering stuff. If I remember correctly from the Diego board, there are 10K pull-ups on that. So we're just going to refit the resistor packs as they came off this board for now. One thing I might look at doing in the future is to upgrade this to, a Rev 6.2. For now though, I just want to leave it as it came to me. So we need 4 resistor packs. And look what I've done. I don't believe this. I have ordered the wrong size of resistor packs. Those are 9 leg. Those were 10. Yeah, that's a mistake on my part. For now, I suppose all we can do is fit them like that. And then I'll just have to fit 1 loose resistor to make up the 10th. Bit of a silly mistake to make. I can always remove these later and refit the correct parts. Just fitting these resistors here on the bottom side. Just think it'll be easier to do that rather than trying to make it off on the top side. I can always order the proper resistor packs and fit them again later. And look at that, there's a big bit of delamination on the bottom side of the board. When did that happen? Just here. Must have been when I fitted that resistor pack. I just didn't notice. Oh well, there's nothing I can do about it now. Goes well with the rest of the damage on this, I suppose. The ultimate plan for this board was to try and sell it on, but I don't know now. Given the problems that it's got just with the damage in around here, if we can get it working, I mean, I suppose it would probably be fine, but I don't know. Right, that's just the CPU socket. And I almost forgot there is one more cap there to fit. For that cap though, we're just going to reuse the original one. I don't actually have any of these. I'll just go back in there. Right, CPU socket. Again, we're just going to reuse this because there's nothing wrong with it. It's a brand new socket, but let's put it on in the correct orientation this time, notch to the bottom. It's probably going to be quite a tight fit because of all those wires that we've put in. We'll just make off that corner and I'll push on the socket from the other side just to make sure that it is flush to the board. If you can even see what I'm doing, that's better. Do the same in this corner then, and just let's get it done. All those wires that we stuck through, just need to be careful then that we don't bridge anything while we're soldering this up. Some of these points here where we've lost a pad on the bottom side. You know, if I was doing right, I probably should have ran a wire through just to make sure that this is going to make connectivity. But it should be alright. Well, unfortunately, it doesn't work. Just throws this green screen. But let's try and stay positive here. At least it is doing something now. So let's try diagram. And I've got a putty terminal open here, so we should get the serial output as well. And yeah, that is all of the unhappy. Let's just turn that off, and in putty here, if we scroll up, that's just pure garbage at the start. None of that looks right. And then it sort of comes good down here, as in it looks right, although it's full of errors, which I suppose matches up with the green screen. That would indicate a chip RAM error. Although this time when I've turned it on, that all looks okay. Until it's throwing multiple address errors at me, and it has just give up. I think I might be on to something here, and I'm sure some of you were screaming this at your screens, but this 2000 board, it's fitted with an 8372A Agnes. That's so that this 1 meg of RAM here, that can be used all as chip RAM. But when this thing shipped originally, it most likely had an 8371 Agnes. Now that Agnes can only address 512K of chip, so in that configuration, half of this would have been chip RAM, the other half would have been slow RAM. Commodore, though, thinking ahead to allow people to upgrade to this Agnes, added that jumper block. That jumper block at position J101, that, as you can see, has no jumpers on it. For an 8371 Agnes, that needs to be closed between pins 1 and 2. But for our 8372A, we need that closed between pins 2 and 3. In fact, if we take a look at the A2000 schematics, there it is there, J101. So in its normal position, pins 1 and 2 are closed. That routes address line 23 through to address 19 on Agnes. Whereas we have it closed in the special position between pins 2 and 3, routing address line 19 over to Agnes. So that jumper is just changing those address lines to Agnes, basically telling it whether we want 512K of chip with 512K of slow, or just 1 meg of chip. We want 1 meg of chip because we've got the 1 meg Agnes. Without that fitted though, well, that address line A19 into Agnes is just going to be floating. It's not going to be doing anything. So I think that's why we're getting those address errors. So we've got a jumper there over pins 2 and 3. Let's see what it does now. I sort of expected that to work, but rather it's just made a fool out of me. Unimplemented instruction detected. System halted, not enough resources found to generate better dump. I did think that was going to make the difference. Yeah, no, it is very, very unhappy. Illegal instruction detected, same thing, but just garbage at the start this time. What is going on? I suppose the likely answer here is that we have further damage around this chip. Or maybe there's something else here that I'm missing. Well, it turns out there's another jumper on this board that I should change because we're using an ATX PSU, not the original PSU. And that's this one, jumper J300. That selects where the tick signal comes from. When this thing was in its big box originally, its PSU generated the tick signal. But our ATX PSU isn't doing that, so we need to change that jumper. Oh, that jumper's broken. And let's get a new jumper, and we need to put that onto pins 2 and 3. Although, to be honest, I'm not sure if the tick signal missing would stop the machine from booting. as I understand, that text signal just feeds into the video side of things. So it might disrupt the video output, but certainly the serial output, I don't think it would affect that. Regardless, so we have it now, emissions 2.3, so this thing is generating a text signal internally. Let's see if that makes any difference. Now that's interesting. It started up there through an error, and now it all seems to be working fine. In fact, it has booted diagram. We have the menu. Let's see if we can test the detected chip RAM. And yeah, it's made it right round there. It seems happy enough that we have 1 meg of good chip RAM. Something does seem suspect to me though. Yeah, it seems to be booting diagram again okay this time. No errors at all this time. Let's back to the menu. Let's try its original ROM again. And it's back to a green screen. Let's go back to diagram. And again, that seems to be working. Okay, some further testing, and look at that mess of hot garbage being spewed out over serial. But if I bend this board, just ever so slightly, well, it's still giving failures, but all the text is now correct. If we bend it the other way, there's all the garbage back. So I think that we do still have a problem, and I think it's bad joint in here somewhere still. Well, I've found it, and I need to say a massive thank you to Pillock over on Gadget UK's Discord, because I shared a screenshot of the diagram output over there, and as soon as he seen it, he said data line D0. And sure enough, if we take a look at that, from the CPU to the ROM socket, well, that makes connectivity there fine, but it should also make its way over to U105 here on pin 2, and it doesn't. Data line D1 should come across here to pin 3, and it does. So where's the break? Well, if we follow it back down here beside this ROM socket, we have connectivity from the CPU to that pin on the ROM, but from that pin on the ROM to U105 with nothing. So that trace from the ROM, it runs along the board here, underneath this side of the ROM to this via. Makes connectivity there. Between that via and that point, that's where it's broken. Now, if I try and flex the board, and in particular if I flex it up, there you are. Let go, it's broken, flex it, it makes connectivity again. That is the problem. So it must be a hairline crack just in the trace here as it joins that via. As you can see, that old ROM socket is a little bit crusty. It's obviously been cleaned up by whoever tried to repair the battery damage here originally, but I can see shades of green corrosion in there. So I think what we'll do is just swap it. I have plenty of those sockets. Let's get that pulled out and we'll make a repair just here on the board in the same manner as we repaired around this CPU socket. Right, let's see if it works now. Not going to bother with serial. Feeling confident. I think it's going to boot diagram. Looking good. Yeah, I think it's working. Now we could run the suite of tests within this, but I prefer Amiga test kit. So give me a second to hook up a floppy drive and we'll try that. Just hooked up this GoTech, but before we stick the USB drive in, let's see if it will first of all boot to its own Kickstart ROM. I think that's a 1.3, and yeah, that's what it is. So USB should just boot us into Amiga test kit, and yeah, there we are. So memory test, let's just do another quick test of that, of the 1 meg on board here. We did test this earlier as well, and it was okay, but let's just do a full test now, considering that we have repaired that trace damage. Yeah, it's been ran a couple of times. I'm happy enough to call that for now. I'll give it a more thorough test later. Keyboard, I suppose we could hook up a keyboard, test this port. Just got my A500 to A2000 keyboard here. Yeah, that all seems good. Yeah, one fully working keyboard. Controller ports. Well, mouse port works okay. Joystick port. Yep, that's okay. Audio. Sounds okay to me. Low pass filter. Yep, that's all working fine. Video. Looks good. Yep, that's all fine. CIA and chipset. That's all good. I suspect if we had that tick signal, you know, on the other two pins there, on pins 1 and 2, as in it was looking for a tick signal from the power supply, I suspect that might fail. In particular, this bit here, CIA, time of day, and the expected ticks. Real-time clock. Hey, no clock detected. But that is the clock circuit there. So maybe that chip's bad. I think it should work okay without the battery in. Maybe there is some further damage down here. Not particularly worried, as I never really use a real-time clock on any of my vintage machines, but well, I suppose it would be nice to try and get it working. And then serial and parallel, we need the 2 dongles for that. But serial test, that's all good. And parallel test, that's all good. So potential problem in the real-time clock circuit, that'll need some further investigation. But before we close off today, I want to stick a Zorro card in. Let's just stick a RAM card in, and I want to see if that's detected. Okay, we've got the Gotta Go Fast 2000, so stick that in a random Zorro slot, number 2 there, and let's see what it does. It doesn't seem too happy, does it? It's not successfully booting there. Let's just try a reseat. Try one of the other slots. Yeah, it's just doing the same thing. Let me try something. I want to try this 3.1 ROM. Now, I know it says A500 on it, but it's the same thing for the 2000. It should just work on here. Just because this ROM has the early boot menu, and if it does start, we can go in there to see if the card is working, or if it's detected, or what might be wrong. Let's hold down both mouse buttons. Yeah, look at that, defective. But I know that card's fine. Let's try one of the other slots. Yep. Something's definitely wrong on the Zorro side of this board. But I think we'll leave that for next time because, well, we otherwise have a working Amiga 2000. That's really just what I wanted to achieve in this video. We've repaired the damage. I think we maybe caused a little bit of damage too, but it's working again. I'm happy enough at that. And next time we'll try and figure out the Zorro slot issue and the real-time clock issue. There's a couple of other things that I want to try and do to this as well. Someone's went to the trouble of putting the ECS Agnes in here, so I think I've got a spare ECS Denise. We can swap that into there. But here's a question for you. Should we try to upgrade this board? Should we try to bring this up to a revision 6.2 or as close to that as possible? The Rev 6.2 used different RAM here. We're not going to muck about with any of that. All that RAM is fine. I did run a more extensive memory test. It checks out with no problems. But Commodore did change a few things on the board. You know, these resistor networks here are different, as I was talking about earlier. And I think there's a couple of other pull-ups or pull-downs. Certainly a couple of other things were tweaked between the Rev 4 and the Rev 6 boards. So let me know what you think. Should we try to do that? Or should we just leave well enough alone and concentrate on fixing the remaining couple of faults? I'm going to do the rest of the recap in between times. You've seen plenty of recapping before. I don't need to cover that on video. And to be honest with you, I can't really do it now because I'm just about to run out of solder. I'll have to order some more of this. But that's going to be it for this one. So thank you very much for watching. Hopefully you enjoyed this video. If you did, I would appreciate a thumbs up. Why not hit subscribe if you haven't done so already? There's still plenty more yet to come here on CRG, and I'll see you next time.